y is equal to cosh to the power nx. And remember that that means cosh x to the power n. We want to show that d2y dx squared is n squared cosh to the power nx, take away n minus 1 cosh to the n minus 2x. I don't see much of a way around this other than to just simply do the differentiating. So the first differential is really not too bad. Remember, just standard n comes down in front, reduce the power by 1, and multiply using the chain rule by the differential of the inside. So that's going to be sine x. But when we come to do the second differential, we need to remember that this is a product. So I'm going to let u be equal to n cosh n minus 1 x and v be equal to sine x. du dx then is going to be n minus 1 cosh n minus 2 x sine x, again using the chain rule, and dv dx is going to be cosh x. So d2y dx squared is going to be n minus 1 cosh n minus 2x sine squared x, and then we're going to have the u dv dx, which is going to be n cosh, and we're doing n minus 1 times a single cosh x, so that's going to be cosh nx. Okay. What we're now going to do, since the result has no shines in it, is think about the fact that cosh squared minus sine squared is equal to 1. So that sine squared is going to be cosh squared take away 1. So we've got n minus 1 cosh n minus 2x cosh squared x take 1 plus n cosh nx. So that is going to be n minus 1 cosh nx take away n minus 1 cosh n minus 2x plus n cosh nx. Now, this one's going to be n squared cosh nx, take away n cosh nx, take away n minus 1 cosh n minus 2x plus n cosh nx, and we can see that those two are going to cancel out, and that is going to leave me with n squared cosh nx, take away n minus 1 cosh n minus 2x as required. Now the second part of A asks us to determine an expression for the fourth differential. Now we can certainly start with the expression for the second differential that we just found and differentiate it twice again. That's going to be slightly harder than what we did before because there's just going to be that extra term to deal with, but it's the same process. However, there is a better way. What we can do is use this that we've just found as a formula for doing two more differentials. So if we think about d4y dx to the 4, that is the same as differentiating twice n squared cosh nx. Take away n minus 1 cosh n minus 2 x. And of course, we just differentiate term by term. So you can think of that as being d dx squared of n squared cosh nx. And then take away d dx squared of n minus 1 cosh n minus 2x. Okay, we know that the n squared here, and similarly the n minus 1 here, can just be taken outside. So we've got n squared d dx squared of cosh nx, and then we've got the n minus 1 d dx squared of cosh n minus 2x. Now, this part is just what we did before. So what we have is n squared cosh nx, take away n minus 1 cosh n minus 2x. Then we've got take away n minus 1, and all we need to do is apply the formula, but with an n minus 2 instead of n minus 1. So what we get there is n minus 2 all squared cosh n minus 2x, take away n minus 2 n minus 3 cosh n minus 4x. So we can expand all of that out, and we get n to the 4 cosh nx, take away n cubed n minus 1 cosh n minus 2x, take away n minus 1 n minus 2 squared cosh n minus 2x, plus n minus 1 n minus 2 n minus 3 cosh n minus 4x. Now, there's almost certainly some simplifying that can get done between these terms here, but for 2 marks, I don't think we need to do it. I think what we've done is sufficient for the marks. So now we just need to approach part B of the question. Hence determine the first 3 non-zero terms of the Maclaurin series for y, giving each coefficient in simplest term. So we know that the Maclaurin expansion will be f of 0 plus f dashed of 0 x plus f double dashed of 0 x squared over 2 factorial plus f triple dashed of 0 x squared over 3 factorial, so that's an x cubed, and f 4 0 of x to the 4 over 4 factorial, and so on. Now, we know that this one and this one are going to be 0. And the reason for that is that both of those contain shines, and shine of 0 is 0. So, remember the f is cosh nx. Cosh of 0 is 1, so this one's just going to be 1. Now, let's do them separately actually. So f of 0 is equal to 1. F double dash 0. Okay, so that's using our second differential formula just here. So that's going to be n squared times 1, take away n minus 1. So that's going to be n squared minus n squared plus n, which is equal to n. Now, the f40 is going to be using the formula that we have just here. So that's going to start with an n to the 4. Then it's going to have a minus n cubed n minus 1. Remember, all the coshs are going to be 0. Then it's going to be a take away n minus 1, n minus 2 squared. And finally, a plus n minus 1, n minus 2, n minus 3. Okay, so a bit of algebra to do here. So we have n to the 4, take away n to the 4 plus n cubed. And then for these two terms here, we have a common n minus 1. And then we'll have an n minus 2 squared, take away n minus 2, n minus 3. Be careful with the signs there because I took a minus out here, which is why that second one's negative. So that's going to be n cubed, take away n minus 1. And this is going to give me n squared minus 4n plus 4, take away n squared minus 5n plus 6. So that's going to be n cubed, take away n minus 1. And then what are we going to have here? So n squared take away n squared will go. And there's going to be an n here and a take away 2. So that is going to be n cubed, take away n squared minus 3n plus 2, which is n cubed minus n cubed plus 3n squared minus 2n. And those go, which gives me 3n squared minus 2n. And now we have those coefficients. All we need to do is substitute them in up here. And so we will get that y is equal to 1 plus nx squared over 2 plus 3n squared minus 2n x to the 4 over 4 factorial, which is 24.